Thank you, Satya. So, our first speaker, I don't think he need an introduction. Vishwanath Swami. He has been seen a lot in the community of .NET. So, I'll just make him on the screen, and Satya, I'll remove you from the screen for now. Now he's already here. Now his first session is microservices using .NET 8 and DAPR, which is one of the most exciting topic. And we know microservices has been leading these industries for now, and it has solved a lot of problem when it comes to complex application or large model application. With that, he will be also introducing service to service communication with the DAPR. So over to you, Mr. Swami. You are muted, sir. Let me unmute you.
Am I audible now?
Now, yes, perfect.
Okay, thank you. Hey guys, greetings. Thanks so much for joining. This is Swami. That's my introduction. And I'm a learner, lifelong learner. So I apologize if I do any mistake. And the next thing is you've already boarded an express train. So please fasten your seatbelt. There are a lot of things we'll be doing today. I'll quickly walk you through this. What is that we're going to do? This is a big picture. Okay, first I'll go through this big picture. Um, our focus is purely on service to service invocation, whether it's microservices or the distributed application. We'll see what is DAPR from a 30,000-foot view, and then we'll go through what all the components it supports and everything. We'll look at it, and then we will see how two different services we have and in how many ways we can communicate with these two services. We'll look at it. One is full-blown API and another one is minimal API. And then we'll see the DAPR dashboard, which shows the services as well as the applications which it is running. And then what is service to service invocation? How DAPR is supporting us in the service to service invocation and the name resolution. What is this name resolution? And then we'll see the resiliency, which is very important piece in any application. Maybe it is a monolith and it speaks to the other service, or when it is microservices or distributed applications, you need to speak to other service to get some of the data. So the timeout is very important, and the retries and the circuit breaker pattern, which we will look at it. And then we will see some of the ways how we can hit those services. OK, so that's about it. So the first topic of this day, I just given a big picture. What is the thing which we are going to do in next 30 minutes or so. So I'm switching on my timer so that it will buzz it the moment we have it. I bought a lot of URLs and I have added it here. So let's look at it right from the official documentation instead of I copy pasting it and changing it. It's a portable event driven runtime, which makes resilient, stateless, stateful, everything it provides. We'll see one picture and then we can go. I've given all the URLs here. At different sections I've given it. So all the tabs which I've opened it, I embedded those URLs in the documentation. And I'll give you the URLs. This is my main GitHub repo, where you'll see what is that I'm doing all the time. And this is the speaker series. As I'm a community speaker, I'll speak at different events. So all my events documentation or a demo script will be here. And this is Tech Skills Academy. This is something which I've given a name. And inside that, today's session is DAPR. So you will find the entire source code will be in that. So I've given that links. So let's come back to our topic. So see this DAPR, what it provides is it provides multiple languages like Go, Node, Python, .NET, Java, C++, lot of development SDKs it has, and also it provides the components. So it provides all these services which are pretty common to distributed or microservices, service to service communication, like state management, publish, subscribe, binding, actors and secrets. A lot of other things are there, but our goal for today is we'll stick to service communication. Like we have observability, security, and resiliency, everything baked in. So we have it supports multiple languages. It supports a bunch of components, and then it can be hosted on premise or on different um, cloud providers. Okay, so the Microsoft started this, and now it open sourced it. That's the introduction. So these are the building blocks. So today's our goal is to stick to the game plan is service to service invocation. Okay, resiliency is part of that when you talk to service to service invocation, like, and also it has got the retries and timeouts and circuit breaker pattern. So that's about the introduction of what is this DAPR from a 30,000 foot. It's a cloud native computing foundation CNCF incubated project. It started with Microsoft started it. Now it open sourced it. And that's what the 30,000 foot introduction of what is DAPR. Now let's see two microservices which I have created. Now, if you really go to the terms of microservices, there are 10 to 12 bulleted points to call something a microservice. It has to pass through all these checklists. Similarly, cloud native application, it has to pass through some checklist. So even though I'm using the high sounding words, technically this will be a microservice or a cloud native application. Okay, so I'm not going through all the checklists saying that, hey, to qualify this as a microservice, it has to go through all this checklist. Okay, but the end goal is imagine this application, a piece of this code is being deployed as a microservice or an application inside a distributed, a piece inside a distributed application. So first we will see a couple of things, the solution which is here. And everything, whatever I'm showing on the screen, everything is there in the URL. You guys go grab it and you can start playing it. OK, so the first thing we'll see application core, where we have set of URLs. I'll do a cleanup, but at least I'm using this one. So this is one of the ways suggested by industry expert Steve Smith. Gave like all the strings can go into the application core where you can have a partial class on the constants and save it there. So as of now, I mean, this I'm going to evolve it over the months, but this is a starting point. So we have a couple of entity classes as of now, items, order and order item. These are the three things which are available, which is there in the data project. And now let's come and see the first microservice is the orders microservice. And you can see that this is the .http file, which we will use it to hit the application, which is you can hit it directly or you can go through the DAPR. We'll see that what DAPR, how it enables, we'll see that. And from the program perspective, you will see only 4 to 5 lines. So everything is moved into the extension classes. So anything you want to load into the dependency injection container, the service collection, we will do it in this extension method, and configuring the HTTP pipeline, we'll do it in this one. So our program class is neat and clean with 5 to 6 lines, nothing more than that. And also you can see the controller has got a single method. It is API controller. The name is orders. And you can see the HTTP post, we're calling it as order, like orders/order, a submit order. We are submitting the order. And you can see some of the things as a good citizens. We are marking it like this. It expects from the body and this expects from the services. Services in the sense service injection. So we are injecting it as part of the services here. You're adding this to the part of the dependency injection service container. And here we are receiving it as a dependency injection. And the new thing is we are using the primary constructor. You don't see the parameterized constructor or parameterless constructor. we are using the primary constructor. So a mix of new latest features, we have it. And that's it. Let's see this first service. How do we go and hit it? So we can do multiple ways. First thing is we'll see, I'll come here, debug, start a new instance. And it starts, takes a minute or so. So you can see that it is running in Kestrel. You'll see an extra window over here. So you see that it has come in here, and we can come in and try this out right from here. OK, or I can try it from the Postman with this endpoint 5001, because that's what it is running on. You can see this, it's running on 5001. Or I can pretty well come back to this HTTP file and click on send request. That goes and hits it. But right now, it is hooked up to the DAPR sidecar. So it will fail because I'm not executing it as part of the DAPR. So it will definitely fail. It's an expected behavior. So what I'll do is I'll kill this instance. Let's quickly walk through another piece. And now you can see that the advantage of moving the logic to centralized or the libraries, we are using the same libraries in both these projects. So you're using this core and data here, and you're using the core and data here. So you don't need to repeat yourself in multiple places. So technically, these will go as part of the libraries, but as of now, I included here. So another thing we'll see here is we have full flexibility when it comes to minimal API. So this is a minimal API. So it's not always mandatory that you need to write everything here. Now, if you see whether it is a minimal API or whether it is a full-blown web API, the program.cs is only 2-3 lines, max of 5 lines, excluding the using statement. You see that it's just 5 lines. Both are the same. How is that magic happening? It's one of the ways to the service container, whatever we are loading everything into the service container, we move it to the extension method. So here we are adding the logger factory. So one simple difference you need to note is here the logger factory, we need to inject it. So that way our endpoints will get the logger factory. So DAPR, we are loading it as part of the application service over here in this line, the same as what we did it in the API. So we load it there. So that comes out of the box. But the logger is some special piece which we need to take care a little bit. So now I'll close all these things. If you see, there is no restriction of how do you create the minimal API, whether it is the normal API or full-blown controller API or a minimal API. You have full flexibility, you have full free hand. Like if you see that we have moved all this logic to the extension methods. We have layered architecture. We are using layered architecture in full-blown API. We have layered architecture in minimal API. And we are using controllers folder in full-blown API. Here we are using endpoints. You have full free hand. You can do anything and everything. OK, maybe the clean architecture, layered architecture, all-in-one hexagonal architecture. Like sky is the limit. So no one is restricting you that you need to write it everything in the program.cs. So see this, the routes are, we can map to different routes. We can give a tag and with name. So each of this name should be unique. So that's how it identifies the endpoint. Let's see that how it looks in Swagger. Now what is happening is we have two services, orders and item reservation service. Now order service depends on item reservation service. Order service has taken set of items as part of the order and asking the item reservation service to reserve this particular item for this customer. Now item reservation doesn't have any dependency. Right now I didn't hook to the database, so we'll not get hit with any roadblock. It gives a proper response. OK, so I can always come back and hit the endpoints. We can see that. So this is coming from the endpoints. I don't want to, I didn't do the last moment changes because how we represent slash API in the full blown controller. I have a convention that I use EP or E point or endpoint to specify that, hey, this is a minimal API. So I don't want to do the last moment changes. I forgot to do that last night. So let me stick to the game plan. But before checking in the code, I will make the modifications and do it like see how it is slash API slash controller. Similarly, in my previous demos, I used to do that EP or endpoint or E point and the uh, endpoint name. Okay, so those are the two services we will be playing it, and I covered quite a few things which are not like a best practices, what I follow, and the latest things which are available. I have given that. And let me quickly show you these things that it's .NET 8. Okay. And now let's go to the next section. So we had a 30,000 foot introduction of what is DAPR, and inside the DAPR, what is our focus. Okay. And before that, we will spend 1 minute of time. So to install the Docker, what is that we'll have to do it. We need to install that. You can come in here. You can use the PowerShell or Winget. That's a package manager for Windows 11. You have it. And I think Windows 10 also supports, but I see Windows 11 has got this Winget, like how you do sudo apt-get and npm. It's like there's a package managing stuff. And we have the MSI. You can click on this release. You will see bunch of releases. 13 is the one which is current release, but at least the stable one is .12. So I have .12 on my box. So then we can verify, and then we can initialize this DAPR in two different modes. So one is the always you need to have the evaluated terminal. So one you can do DAPR in it. This is running locally, and that's called the sidecar pattern. We will look at the sidecar pattern in a minute. And what you can do is you can initialize this either either as a local mode or in the Kubernetes mode. So as of now, I'm running in the local mode. So I can come back over here and I can say DAPR. You can see it has got everything, and DAPR version. If I see DAPR version, you can see the CLI version is this, and here the runtime version. So you need to have Docker running, or you can, because if it is local, you need Docker. And if you're deploying it to Kubernetes, you need to have Kubernetes. So at this point of time, some of the things which comes out of the box is this placement, Zipkin, and Redis. So without going deep into the weeds, let's stick to the game plan. I just wanted to show you what is that it takes to install. Okay, we have seen the installation piece, and we will come back to service invocation. So we'll come and learn about that. Hey, Rizwan or Satya, did something change on my box? I don't know. I just clicked on that button. Everything
So
is
far, so far,
everything
all
is good.
okay. Yeah.
All is well. Okay, thanks. Thanks so much. So how does this communication happens between the service to service? So if you see, there are multiple ways we can have service communication, or technically, let's stick to the word called invocation. Like in our application, service A calls service B. You can call using HTTP, or you can call through the gRPC, which is a bit faster than HTTP, or you can have a remote procedure call. There are multiple ways. So you can have synchronous calls, or you can have asynchronous calls. So synchronous call is you make a direct call request response. You hit that service, it gives you a response, done and dusted. So asynchronous call is you drop a message to the service enterprise service bus ESB, or let's call it in a simple term service bus. Service A drops a message, service B picks up that message, it does the processing and put the response back in a message and A reads it. Now you have a kitchen knife and a chainsaw. You need to cut a tomato. Which one do you use? You can use chainsaw or you can use a kitchen knife, but you need to decide what is the right tool for this job. So if at all there is a financial impact, I would say that you need to use asynchronous communication where the completion of this transaction or the completion of processing of that message is very, very important. So you need to use this asynchronous one. So if at all you go and get a data from the table and spit it on the screen, you don't need to use that service to service communication using the messaging protocols, because that's like a kitchen saw. You're getting to cut a tomato, you might cut your fingers or you might break the kitchen platform itself. So use the right tool. Okay, so those are the things. Now let's come to this service to service invocation. Now DAPR facilitates this service to communication. You can see that we can it provides that when you execute any of these services using the DAPR. So that means what happens is a service gets executed and the DAPR executes as part of the um, separate process in the local, like a service A and its corresponding sidecar DAPR, service B and its corresponding sidecar DAPR. So every time you run a service, you have a sidecar DAPR running paired with that particular service. So that enables it. Now I've given all the URLs, guys. Let's see that visually, how the service discovery, how it happens. We'll see that. So you can see that a service A and its both of them get married, a service and a DAPR sidecar, a service and a DAPR sidecar, both get married like two couples. They are there. Now, if a service A wants to talk to service B, service A hits the DAPR sidecar. The sidecar goes and speaks to the name resolution and it says that, hey, I know this, it exists here. It gives this name resolution and then it goes and talks to the sidecar. It doesn't go and talks directly to the service B. It talks to the spouse of the service B, the DAPR sidecar, and then DAPR sidecar will go and hit the service. So that's the communication. Service A hits the sidecar, its own sidecar. Okay, they both got married, service A and the DAPR sidecar. So service A speaks to the DAPR sidecar and DAPR sidecar goes speaks to the DAPR sidecar of the service B, and then it goes in between. The name resolution gets resolved. So here you can see that name resolution, which identifies by the local name. So let's see that how to run a service using the DAPR. I've given all the commands, folks. So please get ready for that. So here is the command. We are running the first service. I'm here and let me come back to this one. Let me execute this command. So you can see that there'll be a bunch of these things. It will flush it out, all these logs. And you can see it does a building and binding. Everything is done. Here it gave that the direct port is 5000 and the DAPR port is 5010 that we have specified it. We'll see that. I just want to quickly, we have 9 minutes more. So I'll just quickly go through direct hits to that. And I'm executing the second service, the items reservation service, that I'll execute it in this tab. We'll see that that is also executing. Now visualize. Let's come back and visualize these two things over here. Now this is order service. It has got its own sidecar DAPR. Now this is items reservation service. It has got its own DAPR sidecar. OK, now I can come back to the endpoint which I've given here. We can communicate two ways, but the suggested way is through the DAPR. Why? Because at this point of time, if I'm hitting this, it will go and speak to that service B, the items reservation service. But what if its IP has changed? So then it will be very hard if you do the direct these kind of communication. Now, if you go through the DAPR, what is happening is the DAPR sidecar and the name resolution, all three guys are in the game, who knows that how to go speak to that. So it recognizes with the local name. So if I come back over here and we'll see the DAPR dashboard, DAPR dashboard, and we can come back and do DAPR list. I do the DAPR list. So it recognizes with these local names. So this is the DAPR dashboard. I'll quickly come back to this one and I will be here. You can see that in 2 minutes. How does it recognize? You can click on that. You see this app ID or the name. So that's the name it recognizes. Right now, we don't have any stateful actors. And I can come back over here and then reserve item reservation service it recognizes. And these are some of the components it has got. And this is the configuration, which is there. Let's come back and see how do we hit it directly. But don't do it. Always go through the DAPR sidecar. Now the sidecar is also running. Even if I do previously, it failed because the DAPR was not running. So we will see this. I'll come back over here and first thing is I'm hitting the order service. That's the direct. You see that port 5000. That means I'm doing a direct hit. You can see that it has given the ID. Let's see the logs over here. So it made the call and then it would have called this one also. So it has received the item reservation for cookie one and it did that. Now let's go through the DAPR. So that means we are calling the port 5010. So that means we are going and hitting the DAPR directly. So when you go and hit the DAPR, see how the logs are a little different from that. So see here what is happening is when in the previous hit, when we hit that, it came and went through this. But now if you see that the logs are a little different because now the DAPR has come into the picture. OK, here also it was there, but the endpoint what you were hitting was a little different. So you are hitting the 5001, that is the local or the direct hit. Now we are going through the DAPR. So you don't see that port number here. You can see this, the first hit, whatever we made, you see the port. That means you are going through directly. You're not going through the DAPR. Now here you're going directly through the DAPR. So you don't see these logs 5001 anywhere here because everything is taken care by the DAPR. So it comes and it hits it, and you can see that this will be same whether you hit it directly or whether you hit it through, until unless you are communicating from this item reservation to the payment gateway or the factory or to the inventory you're talking. So it will be a little different in that case. Now, another thing which I would like to highlight over here is, let me come back to this one. We'll see the timeouts and the resiliency, and we'll speak about that in a minute. Before that, timeout, that's over here. But let me quickly walk you guys through the Zipkin, the logger. See that? Come on, come on. Let me show you one more thing. From here, I'm hitting to the direct one, and this one I'm hitting through the through this DAPR. That's one difference. And now let's speak about the timeouts. I'll try whether did I do anything wrong? I don't know. Let me check that. Let me come back to that one. So now there are couple of things we need to consider when we are hitting from service A to service B. So imagine for some reason service B is down, maybe a temporary network blip or a permanent issue. So service A default timeout is API to API is 30 seconds. So do we need to wait for 30 seconds? And imagine there are 100 calls hitting service A and service B is down. Each of those calls waiting for 30 seconds. It might bring down the service A also. Right now, the service B is down, it might bring down. So timeouts is very important, which we need to consider. And the second thing is retries. The retry is when you're trying to do a resilient one, a transient failure is there. So that means we can retry. What if it is 401? So no matter whatever you do, try it how many times, it will not go through. Or unauthorized one. So these things doesn't make sense. Only the transient faults, there's a temporary blip, those kind of things we can do a retry. How many times do we need to retry? 3 times, 5 times, 10 times? That depends upon what is the SLA between for the solution. Okay. And another thing is after making 3 to 4 tries, there might be some of the DBA is restarting the database. It might take 10 minutes to come up. So don't allow any more traffic. You know that it failed for 5 times. What is the point of again going and hitting when the server itself is down or someone is bringing that server restarting the AS or something of that kind is happening. So that's the one. This one is the circuit breaker pattern. OK, so imagine a scenario when you have everything is good and something gone wrong. In that case, it will open. That means it will not allow anything more than that. So then what happens is after 30 seconds of wait time or 60 seconds, whatever we configure, it makes half open, like it allows one of the requests to come in. So if at all that goes well, then it will close the circuit. Let's see that in action now. So I'll come down and I will kill this, the service B. Now what is happening is we are replicating 3 things here. We are replicating the timeout, we are replicating the retries, and we are replicating the circuit breaker pattern. So cross the fingers, we are going through the DAPR. I just clicked on it. Let's come back and watch the logs over here. So this is already killed. Now you see that it says that we are retrying. So the first hit, and then it's hitting for the second time, it's retrying, and then it did the third retry, and it said that no, I can't do any more of these. And then it said half open. So now it's half open. Now let's compare with this. So it's failure and it is open. And after 30 seconds of timer, it makes it half open. So from half open, it said that, hey, I can't go through any, it made the try and it said that close to open. So it was closed and it is open at this point of time. You can see that if I make another call, it clearly says that, hey, I can't process because the circuit breaker pattern, its circuit breaker has switched it on. Right now it is open. See that circuit breaker is open. So now if you wait for 30 seconds, if you wait for 30 seconds, let's see that it didn't go through because it found it's retrying, it's making the retry. What we can do is we can come and execute it. So now this service has come back. Now I will come and make this. Let's observe that. So half open to closed. So that means it made a call and the call went through success. So then you can see that it was half open, and from half open, it closed it. I think the timer is on. So my 30 minutes is over and we saw
Uh,
that.
but if you have anything more to present, you can some extra time. That's fine. So,
Okay.
because it even interests me also. So I'm sure like
Okay,
our
sure.
audience might be interesting with this.
Sure, sure.
And also
So
I
it,
saw there are some questions also for you. So you can complete and later we can
yeah,
discuss the
yeah,
questions.
sure, sure. So now what it made is it made these things. So these are pretty important because from our perspective, we see that um, we have tools, but we need to choose when to use it. Okay, so timeouts. So we have a lot of libraries which definitely supports. Someone can ask, what is that DAPR bringing in? So can't we do it programmatically? Yes, we can definitely do it. But did I do it any of those things here? That's the first question. No, I didn't write anything, whether anything, poly or something else. What is that? I did it. I just picked up the um, policy from this one here. If you see that, I just picked up this resiliency policy. So the resiliency comes with 3 things. The resiliency, at least here. We have timeouts, we have retries, we have circuit breaker. So timeouts is what you should decide what should be the timeout. So in 2010, around that time, 8 seconds when you make an API call from UI, when you make an API call, the internationally accepted was 8 seconds. Now, is it acceptable in 2024? No, we don't have time for 4 seconds. 8 seconds is too much. So you need to decide that when service A calls service B, when you should say that it failed. OK, and when the transaction happens asynchronously, in that case, most of the things is you drop a message, the other service picks it up and just acknowledges that, hey, I received the message. You don't need to wait until the entire transaction gets completed. Like service A calls service B and service B calls the third party payment gateway. It might take time. You see Amazon, you just sometimes you order it and the moment it takes 8 seconds or 5 seconds, whatever the time it says that shows that payment would have failed. We are trying. Please come back and visit after 20 minutes. It does that. So those kind of things we need to do it like that. OK, and retries and back off. Retries is two ways we can do a retries. So service A calling service B every 5 seconds, it does a retry. 3 retries or 10 retries, whatever you and your team decides, we can do that. That's one way to handle it. The other way to handle is if at all there is imagine the container has blown and it is creating a new container and that has got some dependency. It's going to take 15 to 20 seconds time. So other way is to back off, exponential backup. So first thing is it makes the first try at 5 seconds. And for the before it makes the second retry, it might wait for 15 seconds. And for the third retry, it might wait for 30 seconds. So that's the good way to handle. I'm not telling the other way is bad, but for this kind of transient errors where the network itself is coming or one of the database has been rebooted. So in this kind of things, so by the time you do a single retry, single set, what single retry in the sense 3 retries or 5 retries, whatever is the retry you can do with the fixed amount or with the exponential backup. So exponential makes sense. Sometimes imagine a scenario, it's a Docker container which is running within 2 seconds, the container comes up. So in that case, 5 seconds and 5 seconds, the straight flat retry might work. Sometimes if it is a bigger restart or a couple of services are coming up, in that case, the exponential will be good thing. So we need to decide. I mean, it's not a one-stop solution. We need to see that what is that which works good. Now the circuit breaker pattern also, we have seen that when you have a circuit breaker pattern, when you know that the service B is not responding, it doesn't make sense to send more of those things, calls and clog the network or bring down other services. So you can stop that. That's the thing. And I think I've given all the URLs. Let me come back here. So we can take
So,
queries.
all right. So first question is, what are the advantage of using common logic and core data? I core or data common. It is a microservice. Is it violating the microservice concept?
No, see this, good question. Now, if you see that EF core is a library and Microsoft has created this library and at least 50% of the world who are working in .NET, they use this ORM. So the intention of the common library is that you create once and you use it many times. Now, if you see, most of the product-based companies, one of the architect or the previous architect, what they do is they will create a reusable libraries. Now take the example of this Angular app. Now in product-based companies, do you think that they will start with a blank solution and create forms and fields and other things? No, someone would have already written the framework UI framework. And all you need to do is customize, and they'll say that their own company name dot text box and give the foreground color, the border color, how the functionality should work. So the intention of the libraries is it helps you create faster to the market. Okay, the initial hit is that you need to create that and you need to work. The flip side of that is if 10 of the teams inside a company is using the common library, if there is an issue, you can fix that issue. All the 10 people can use it, but you'll have a little bit pressure until you fix that bug. And another thing is if you release different version. So team A can stick to the version 1, team B to E, they can use version 2, and team G and above, they can use version 3. So that's the other advantage is the same library, different functionalities, different teams can use different versions and they can upgrade it when they are free. So there are a lot of advantages. There are disadvantages also. Everything is like a double-edged sword. Yep.
Yes. Yeah. Another question like where can we see the checklist for microservices and cloud native apps like to qualify it is microservice or cloud native apps? Do we have any checklist where we can
Oh
verify?
yes, yes, we do have.
Okay.
There is something known as I'll give you this. This is one of the link. Copy the link address. I'm pasting it here. Uh, this is one, and another thing is. Uh, so we can see this one. What are microservices? Whether it is from Amazon or from Azure. Now, if you plainly go to microservices.io, in that microservices.io, in that you can see that it's like loosely coupled, independently deployable. So each should have its own CI/CD process, their architectures. A lot of things are there in that. You can see different architectural patterns. No, that's there. And for cloud native, also there is again a different checklist. What I do is one is I'll give that list to you a little later.
Yeah, later we can share this. Yes.
Yeah, so that offline we can you guys
Yeah.
publish it.
Yeah.
Like,
Someone is interested with your course, so he's asking, do you have the full course where I can enroll or watch in YouTube?
oh yeah, yeah. Generally, when I come and speak in another meetup group, I don't do marketing, but someone asked it, I'm doing
Right.
it. This is the first time I'm an organizer of this meetup group,
Mhm.
and I have my uh, uh,
Just post in forum.
yeah, this is my YouTube channel. So I will be, this is the playlist. I'm speaking on this microservices and Azure OpenAI, AWS, a lot of things I'll do it. So you guys can enroll to this meetup group, and this is the .NET Learners House. And I'll keep a watch on this folder where every year I do 40 to 50 events. So
Mhm.
this is my calendar for Jan, Feb, and March this year.
All right.
Okay.
Okay, and another one, two more questions are there.
Oh,
So
please
one
go ahead.
question is,
Mm.
does DAPR impact the performance? So,
These kind of questions we have to do a tech feasibility study or a spike.
uh-huh.
Because it these kind of things we can't tell directly like dapper impacts of performance or it's a generic question. So we need to see that what is your P1 use case? You need to take the P1 use case and what options do you have? Like, do you want to use Aspire or do you want to use your own microservices, set of services, and use Poly to create the exponential backup, retry, and circuit breaker pattern?
Mm.
You have to try that, and then you will come to know that whether writing your own code is working good or whether using DAPR is working good. See this, there you will write the code. If you don't use DAPR you configure it. So we have to try what is the use case, what is that you're trying to do. A lot of things will come into the picture. Yeah, just that you asked, I don't want to tell that DAPR is
Yes.
good or your own
Yeah,
code is
I
good.
agree with you because even
Isn't
I
it?
was doing one project with one of our clients. So she was insisting me like, okay, give me exact performance time. It's a very big. It depends upon network server configuration. Even same server,
Exactly.
same configuration. If you are using multiple times, the response are different. No, so we
Simple
cannot.
thing.
Yeah,
Yeah,
we cannot.
simple thing is what I do, how I do. Yeah, you are exactly right. Until we do a feasibility study, there's a tech feasibility study. We
Mhm.
can't tell that whether it's good or not. Even after doing tech feasibility, we might hit with a roadblock. And
Yes,
the
yes.
second thing is we have to do the baselining. Baselining means don't take the bigger hardware or the bigger computing power, take a small app service or a virtual machine and do a baseline testing on that. So what is business asking? Is it 50 concurrent requests per second or 100 concurrent per second? First do a baselining, and then on that lowest computing, you run the performance test and tell that given this computing power, the way we wrote the code, it supports X number of users. We need to have the baselining for everything. Once you have the baselining, then only we can tell that based on this, do we need a performance improvement or this is what it supports. No matter what you do, some you have chosen a framework and the way you wrote the code, this is what it supports. Whether you take the biggest computing power GPU or whatever the CPU, it's
Hello, am I audible?
there is one.
Yeah, you are
Yes.
audible. I think Vishwanath Swamiji is muted.
That's fine. Maybe some technical.
Hello.
Yeah.
Yeah,
Now
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 we
we
can
can hear.
hear you.
All right.
Yeah, you can continue.
Okay, but I'm not able to see you guys. I think I'm in the
Uh,
attendee list. I think you need
can
to.
can you hear me? Can you see
Yeah, I'm
us
able to
now?
hear you. I'm able to
And
hear you, but I'm in the attendee list.
attendee list? No, but I can see like you are already in the screen. Let me. Uh, anyway, that's fine because I can see you. You are already in the
Okay. Okay,
presenting
then cool.
session.
Okay.
Yeah,
So
another one
anything,
question is that is also very difficult to answer. I can see. What is the ideal time we can put for timeout, retries, and breaker, no circuit breaker? So
oh, it's
this
a
is
generic
also
one. Again, it's a generic one.
yeah. It depends upon your requirement. You have to know like how much you want to put your benchmark. What is your range you are looking for your responses. So based on that, you can decide your timeout, retries, circuit breaker. That's the thing.
Yeah, you need to do a study and get the from business, like what is that you have to do it. So based on that, you need to do it. Uh, it's not one-stop solution. It's a double-edged sword.
True. True. So I think that's all. With that, now I think we can move to our another one. Actually, our another speaker, he's having some